My name is Constantine. I'm product-oriented engineer in Playtika, like oriented to solving the business problem, like my previous speakers mentioned. I'm working in Playtika. The mission of Playtika is entertain the world. We do games, mobile games. So people play the games, they pay money. So this is how we make money. The context of my talk is going to be how I do the architecture in Playtika for the game development. Basically, when we start working on the project, we start with uncertainty. Like we need to figure out what to do. This is like 50% of the work. And from the uncertainty, we need to come to the structure. So my talk will be about how we come from here to here, how we build a spaceship when initially we know nothing about it. And to do this, we need a framework. This is my framework, my guideline of how do I propose to make system design decisions in company. We need to start from the business goals. I will talk about what is the architecture significant requirements. We'll cover the stakeholders, non-functional requirements, and most of important stuff. So we'll learn a lot of new words today, and you can come to your job next day and say, okay, now I'm architect. I know all of this. And I like the concept of the Star Wars, and this is one of my favorite movies. So we have Luke, who is the promising product-oriented engineer. He wished to learn a lot. And we have Yoda. Let's say Yoda is a mentor for this engineer. So these guys will make an architecture, and Yoda can say something smart and teach Luke. And architecture is about important stuff. And the architect seems to be the person who worries about important stuff. And important stuff, we call it architecture significant requirements. So this is the requirement. In the absence of this requirement, the system will be dramatically different. It's like if we miss this important stuff, we make completely different architecture. So in the talk, we will only care about important stuff. And something that is not important, like should the button be green or red, is not in the scope of the architecture work. And we are product-oriented engineers, so we need to think about business goals first. Assuming that we are making a game, and we play the game, we play levels, and well, we have a special mission. We need to do something in the game. This is interesting. There is some story behind it. So we were decided to, if I play 3 levels and go to bed, but I have a special mission. I need to play for 1 hour. So this is the way the game can engage you. You can play more, and this is the way. I need to pass this special mission. It is interesting, and we need to make money on this, so we can sell some game resources, and for real money. Like we can earn some Republic credits for people who play in the special missions. This is how it works. We play the levels. We earn some resources, like we earn some diamonds. We play the levels. We collect the diamonds. We have the special missions. We can spend these diamonds in a special mission to pass some quest. And then if we don't have enough diamonds, we can purchase these diamonds. This is when the monetization comes from. So this is how the computer, this is how the game is actually making money. So we have the first version of the architecture made by Luke, and it looks like this. So we have the client. Client is the mobile game. It's an Android, iOS application. In Playtika, we use Unity, by the way. This is the engine that allows you to write code once and compile for multiple platforms. We have some kind of a player inventory service on the backend. It stores how many diamonds you own. Let's consider its service has a small database inside. And we have some mission service. So the mission service knows like which mission you are, where you are in the mission. Like you can have multiple steps, you can have some graph, you can do this, do that, and it's like a state machine on the backend. And we have a database. So, and user can make in-app purchases using the Apple Store or Google Play Market and buy some diamonds to spend them in the missions. It is good. And then we meet stakeholders. This is another new word we have to learn for today. So if we do not know our stakeholders, this is definitely pass to right side. because we do not understand it. We are making the wrong design decisions. We are making the wrong software, and the business fails. So who are the stakeholders? I think the most important skill of the architect is empathy. This is like understanding the picture from the perspective of others. And here is the stakeholders that we have in Playtika. We have a product manager, some game designers. They care about the game to be interested, engaging. They actually think in how to build a game. We have the monetization people. This is how we make money. They think how to sell diamonds for money and make the game earn it. We have economy. Economy is interesting people. They thinking of the balance of resources in the game. Like assume you need to earn 10,000 diamonds, and we have a special missions for you, and you just pass the special missions for 1 day. So the game is not interesting. We need to make sure you spend it, and we have enough missions for 3 months. So you only spend this 10,000 diamonds in 3 months. If we spend it in a 1 day, it's fail. Also, if you're not earning enough diamonds, so you cannot complete any mission, it's also not interesting. This is looks like the real life economy. We have operations. Operations is the person who actually operate the game. So they configure, like, for example, every week we have something new in the game, some new tournament. So they configuring it like how the tournament should be. So the game is not static. You cannot just put the game in the store and make money. You always need to put something new. Of course, we have a customer support. Just in case I can complain, okay, I bought 10 diamonds, but they didn't appear in my inventory, so could you like fix it? We may have some cheaters also complaining to customer support. It happens. And artists are the people who creating art. They making graphics, they making the game looks amazing. So there are a bunch of people who participate in the game development process. And this is how we can look at the game from perspective of those stakeholders. So, for example, monetization, they're interested to make it configurable, and so the special mission can start by any game event. For example, you are playing the level. When you finish the level, then we start a special mission. Or if you lose 3 times, then we start a special mission for losers. If you win 5 times, etc. So they want to experiment, and they want to introduce special missions for different occasions. This is why they like their workflow engine that is familiar. This is some amazing tool. You can say, put some complex configuration and say, I want to start special mission at this occasion, and they want to use it. So the operations, they want to be able to easily configure all of this. They say, okay, we like your workflow engine, but if it requires too much effort for the configuration, we're not able to do it. And the economy, they want to make an A/B test, like, let's try to have some group of users and give them 10,000 diamonds, and they see how much time it takes for them to pass all the missions. Do we have enough balance? They also care about analytics. And the customer support are care, how do we compensate if user says, okay, I paid for and I bought 10 diamonds, but I didn't see it or anything else. So they need to have some approach to see like what is your progress in the mission, why you are not enjoying your game, and maybe give you something back, some reward. And this how the stakeholder requirement impact in the architecture. So you see, we have this architecture, and we have this workflow engine that monetization likes. We have some customer relationship management, CRM, so that can be used by operators and can be used by customer support. So we need to be able to enter the user name and see where the user is in the mission, what the missions are passed, how many diamonds the user have to actually investigate what's going on. And we should have some button, okay, give this user diamonds in case the user complains and we see that there is some mistake and user didn't get what he wants. Also, to make an A/B test, we need some kind of feature switch or service. So we split in the users on the test and the control group. We need to configure it. And for the analytics, we need a data warehouse. This is how important stakeholder requirements impact the architecture. So you see, we put a lot of new components into this. All right. And there is something else that impact the architecture. It's not functional requirements. It's we need to care to we have like 10 million users in the game. So we need to care that game support all of this. It should be secured. Like we may have a cheater detection in the game. Like if the game is easy to cheat, it's probably not a good game. We should be able to monitor this. So there are lots of stuff. And if we put this perspective on non-functional requirements, usually we have some performance considerations or high availability considerations. For example, we can put a queue between the client and the workflow engine, like all the game events, before they go into the workflow engine, we can put them to the queue. So in case of some spikes, the workflow engine will be able to process it. We can also put the queue between the workflow engine and the mission service. Like in case some event happened and we need to start the mission, also we have the spikes. We may turn the communication to a synchronous way. Like I'm playing the game, I'm throwing some events, and then at some moment I need to start the mission. So we want to make a communication back through the WebSocket and notify the client when to show some mission screen. So this is asynchronous. And then we need some kind of a WebSocket messaging service. We want to make this communication reliable. So in case we send the message via the WebSocket, it's not lost. And there we need some database for the messages. We need to remember it. And when the user goes back online, we still be able to send it. And we need to put some entity versioning in the database to handle concurrent updates, because we have like many million users and they can and it could be concurrent requests to the database. If we are sending lots of analytics to the data warehouse, so there is definitely some message queue behind it. So this is how non-functional requirements impact the architecture. And I want to talk about some other important things we need to consider, the constraints and trade-offs. So it usually happens when you make amazing architecture and someone else says, okay, but we don't know if that feature will be actually good, if we make money on this. So the game development is always a bit of luck. So we may think, okay, we introduce these missions, but maybe it's not going to be interesting for the player. So we want to make some minimum available product, let's say a small version of the feature with only few things, and then test it on the test group and see if it makes sense to spend money on this. So this is example of the constraint. So the constraint is usually time, budget. It could be development team. We may have no developers available at this time who can do this work. So we need to make it simple. It always approved technology stack. Like if we have a platform team in the company and they support in some stack, so we taking a big risk if we choose some alternative approach. We would better use something that already established in the company. There could be some company policies of what you should do, what you should not do. Company policies is the good stuff. They put in like a fence on your decisions. So usually if your decisions are falling in particular area, you should use this technology. Like we need to use Iris Spike database for a broad range of use cases. If you have use case that doesn't fit Iris Spike, then you use MariaDB. So this is how we work. Like you need relational database, but we cannot say, okay, we use Postgres, we use Redis. It's very expensive to spread this broad variety of technologies. And when we're dealing with constraints, we usually meet trade-offs. One trade-off is the budget versus the good architecture. And I think this is the trade-off I always have. Then some architectural changes bring the trade-off, whether the communication need to be synchronous or asynchronous, whether we should go with eventual and strong consistency and other. And this is also the really important trade-off. We are not a new company, so we have a lot of libraries, a lot of existing components from the games we built. We can take some existing components and build the feature really quick, but existing components may not fit all the use cases. So this is the trade-off. We take something to build it quick, but we do not do everything we want. And this is how the architecture may look if we apply this constraint. Let's say we want to produce MVP scope. So instead of WebSocket, let's just do polling, because we have no time to do WebSocket. And for the mission service, we wanted to implement a graph of missions with a lot of different branches. And let's say for now, let's do really simple missions because we need to do MVP. And instead of making a proper user interface for the operators for the customer support, let's just have some config file and put this for the MVP. That should be enough. And instead of customer relationship management system, like the interface, when I could put a username and see the progress, I can configure some login filters in Kibana. That can be a cheap solution, but we can still be able to see the user progress. And like A/B test, we can do with a few simple missions, then see if it goes, then continue developing the product. That's it. Then after we make this amazing architecture, it makes no sense if we don't communicate it. It's pretty obvious things. So it's like, relax and take your beer. I'm not gonna talk about something complex. We should pass on what we have learned. And usually I'm advocating for making the high-level design documents and the software design documents. So we have kind of a template, and you put your architecture decisions into this document. And documents things of like agreement when we put those decisions and like make sure that, okay, this is we put this on paper, so we can refer to this document. And it's natural that requirements are always changing. Like we're not waterfall model. And game dev is something you need to try, you need to change your direction, then you need to try again. So it's always changing. And yeah, it's always in motion. And we need to be agile, we need to be quick. So that is nothing, there's no rocket science here. So we just follow these steps. And then if we find some important requirement, architecture significant requirement that significantly impacts the architecture, we come back to the drawing board and then we evaluate all of this. So basically this is repeated cycle. It's also good if we are not lazy to put it in the documentation, which I think 75% of the systems, when I saw the initial documentation, it was not done according to this documentation, but it's actually would be nice. Yeah, that's it. This is some books. If you want to read about this, a lot of books, I can leave the slide, and that's it. Your questions?